Okay, so we're going to look at circle and chord properties today. Just like how in year 9 when we did angles we had parallel lines, so for example we had parallel lines and then we looked at the alternate angles using the Z rule, or we used the co-interior angles using the U rule, or then the corresponding angles with the F rule. With circles we also have angle rules and different properties related to them. So we'll first start off by looking at some different labels of circles, or properties of circles first, and then we'll get into the theorems. So let's say we have a circle, then we have the center of the circle, and then the radius is a straight line from the center of the circle to the edge of the circle. And then the diameter is the distance straight across the circle but passing through the center. And then a chord is a line that just connects two edges of a circle. It doesn't have to pass through the center. So a chord is a straight line that touches the two edges of a circle. It does not have to pass through the center, whereas the diameter is a special case of a chord because it has to pass through the center, and then half the diameter is the radius. And then smack bang in the middle is the center of the circle. Alright, now also, let's say we have another circle. We have the center of a circle. And then let's say we cut a slice of that circle. So let's decide to cut this slice of the pizza here. So this red slice. So a slice or a piece of a circle is called a sector of a circle. In contrast, the crust or the edge of the circle is called the arc of a circle. Now, if your slice of pizza is less than a semicircle, which is half a circle, then it's called a minor sector. And then if your crust of a pizza or crust of a circle is less than a semicircle, then it's called a minor arc. So this red slice here is called a minor sector. So sector, it's a slice of your pizza. Minor because it's less than a semicircle. Whereas your crust, your edge here, is called a minor arc. So arc means it's your crust or your edge. Again, minor means it's less than a semicircle. So in contrast, if you're looking at the bigger slice of your pizza, that is what we call the major sector. So a big slice, a slice that's bigger than a semicircle. And then the crust of that slice would then be called, guess, major arc. So arc for crust, and then major because it's bigger than a semicircle. And then we have a few more definitions. So let me change back to my pen. So let's say we have another circle. Lots of circles today. If we draw a chord in a circle, so remember a chord is just a straight line from edge to edge inside a circle, but it doesn't have to pass through the center. We divide the circle into two segments. So the smaller segment is called a minor segment because again it's less than a semicircle. And then the bigger chunk of your pizza would be a major segment. So and then here is the chord, the line that we slice, that we cut the pizza up into chunks. So the difference between a segment and a sector, so if you go back to a sector, you have to cut through the center of your pizza to get a slice of pizza to get the sector. Whereas a segment of your cookie is just, who cares where you cut it as long as you break apart your circle. And then you get a segment. So now we've got some terminology or definitions of different parts of a circle. We can now go to the different theorems of a circle. And before we do that, we've also got to define a few more parts in terms of angles. So let's yet have another circle. Circle, circle, circle. Okay, I have a center point, it's called at O. I decided to create a sort of straight line. Let's use a ruler. Straight line, straight line. Let's create a slice or a sector. So it touches at point A and it touches at point B. So what we say that angle AOB is subtended subtended at the center by the minor arc AB. Alright, so that's just a fancy way of saying angle AOB, so that's the angle inside here of your slice. The new word we're introducing is subtended, so the angle is subtended at the center O, because the angle is at that center point there, by the minor arc, so the crust A to B. So we're saying that the green angle AOB, is formed by the 2 points A and B on the arc AB and then the center of the circle. But then we use the word subtended to describe that angle there. And there's another way of doing it. So let's draw another circle as well. And then rather than having a sector, a slice, let's just cut our circle up. So I need a straight line. Let me just go jump, jump. And then we will call this point A, this point B, and then this point C. So we can say that angle ABC is subtended at the circumference by the chord AC. Alright, so let's break it down a little. The angle ABC, so angle ABC is that angle of that triangle from your pizza, from a cookie. Again, we see the word subtended. So the angle is subtended at the circumference. So it's the circumference this time, not the center, because your angle is touching the circumference versus the previous definition, your angle O was touching at the center. So angle ABC, the green angle, is subtended at the circumference, the point B, by the chord AC. So chord, remember, is a straight line connecting 2 points at the edge of a circle. So from A to C, we have that dotted straight line, that chord. So angle ABC gives us the green angle there. So angle ABC is subtended at the circumference by the chord AC. That's just another way of describing angles inside a circle. Now let's get down to the chord theorems, which we can apply. Now, at first they look a bit scary, but we can break it down and then actually apply them in some examples. Now, these are on your textbook, page 125. If you just want to photocopy that and paste it into your books, page 125. Now, this is part 1 of, I believe, 3 of 4 parts of different triangle theorems. So I think we've got about 12-ish theorems in total for year 10. Now in year 10, we just need to learn how to apply these theorems. We don't have to prove that these theorems are true. But if you get to year 11 and you're interested in specialist maths, then you'll learn how to prove these circle theorems in year 11. But just for year 10, we just got to learn how can we apply these patterns or rules. Just like how in year 9 or 8, we learned how to apply the alternate angle, the Z rule. Alright, so let's have a look at chord theorem number 1. So chord theorem 1 says, chords of equal length subtend equal angles at the center of the circle. Okay, so all it's saying is, if you have the chord AB, which is this one here, and it's the same distance as chord CD, right? Then we know that the angle formed by subtending at the center, these green angles must be the same. And the opposite is true. So if you know that the two green angles are the same, then you know that the purple chords will have the same distance. So that's chord theorem number 1. And just like how when we did in year 9 with the Z rule, the alternate angles, we had symbols to show that, you know, we're applying the alternate angle of the Z rule. Similarly with chord theorems, we can either write down by using chord theorem 1, or we can just draw a symbol. So the symbol for these chord theorems is literally a miniature version of what you just see in this picture here. So if you want to explain what chord theorem you use to solve the problem, aside from just writing I use chord theorem 1 or I use chord theorem 5, you can also draw the symbol. So the symbol for chord theorem 1 is literally what you see it as. So you have the center of a circle, you have the two chords are the same, and then you have the two angles are the same. Looks like a cat with whiskers. Let's call it the cat and whiskers symbol. We need to find a way to help you easily memorize these theorems. Now, chord theorem 2. Chords of equal length are equidistant. That means they have the same distance or the same length from the center of the circle. So what that's saying is, if you have the chord AB, and that's the same as the distance as the chord CD, then we know that the distance from center O to E, where it chops it in half, AB in half, is the same as OF, where F is the point where it chops CD in half. And the opposite's the same. So the symbol for this circle theorem is literally, you just draw a miniature version of what you see. And in fact, these would also be right angles as well. So aside from being equidistant or equal, they're also right angles. Now chord theorem number 3 says, the perpendicular from the center of the circle to the chord bisects. So bisects means to cut in half. So bisects means to cut a chord in half. And the angle at the center subtended by the chord. So all this is saying is, if you have OM is perpendicular to AB. So you have a chord AB, and you have another line connecting to the center OM, and they're 90 degrees to each other. So then we know that AM is equal to BM. So in other words, M is the bisecting point. It cuts the chord AB in half. And we know that also the angles from the center are exactly the same. So the symbol for that is literally what you see. So center, triangle, a bisecting line, and that cuts it in half, and you've got two angles the same at the center. Chord theorem number 4 says that the perpendicular, so again right angle bisectors, so lines which are 90 degrees and cut in half of every chord of a circle meet back up or intersect at the center of the circle. So let's say I have a chord and I have another chord. I create some perpendicular bisectors. So I create a line which chops it in half and it's 90 degrees to the chord. then I know that those two chords must meet at the center of the circle. And the corresponding symbol for this theorem is literally what you see, a miniature version of it. So you've got two chords, you've got perpendicular bisectors, and then the dashes to show that they're bisecting and cuts it in half. And then they have to join back up at the center. So it sounds a bit confusing because it's totally new angle rules, and now we're dealing with circles. But we'll do a few examples and see how we can apply these circle theorems. So the examples I'm doing are taken from page 126 of your textbook. If you don't want to copy it out, just reference back to that. So example 1, okay. We have to use the information given and find the missing angle or line. So part A says, given AB is equal to CD, so we know that this chord AB is equal to the chord CD, and we know that from the distance from the center to that point E is 3 centimeters. What is O to F? Alright. Now, when we're starting off these circle theorems, you're probably better off having a cheat sheet of all your circle theorems in front of you until you learned it off by heart. So essentially, we're trying to match up out of the 4 possible circle theorems that we've learned today, which one fits the question that we want right now. So we've got 2 chords which are equal, and we're trying to find the distance joining back to the center. So flip back to your chord theorems. I'm trying to figure out the one which has 2 chords and then joining back to the center. So it's not chord theorem 3. We're not really talking about perpendicular bisectors. So 3 is out. We're not talking about perpendicular bisectors, so 4 is out of the game. So it's now a toss-up between 1 or 2. So let's go back again. So we've got 2 chords. We know the distance from the center to E, which is a point perpendicular to the chord AB, and we're trying to find the distance of the other line as well. We're not really dealing with angles here. So chord theorem 1 is dealing with angles, so 1 is out of the question. So all that's left is, let's use chord theorem 2. So chord theorem 2 says, if your greens are equal, then your purples are equal as well. So applying that to part A, since your greens are equal, that means our inside purples must be equal as well. So we can say that OF is equal to 3 centimeters. Why? You can either say because of chord theorem number 2, or remember those symbols, you can draw a miniature version, or you can draw a symbol to indicate that it's chord theorem 2 that you are using. So if you like the words, write using chord theorem 2, or you can do the symbol, or if you just want to make sure everything's all good, then you can write both the words and the symbol. So don't just write the answer down, that the answer is 3, but also make sure you explain which chord theorem you have used to get to your answer. Alright, let's do B. Okay. So B says, we know that OM is perpendicular to AB, and we know that A to B is 10 centimeters. We also know the angle AOB, so this purple angle inside is 92 degrees. What is the distance from A to M, and what is the angle of AOM? Okay. So let's flip back to our circle theorem cheat sheet, our list of them, see which one it fits that we can apply. So we're looking at one chord AB. So flipping back, well, it can't be chord theorem 1 because chord theorem 1 talks about 2 chords. It's not 2 either because you've got 2 green chords. It's not 4 because you've got 2 green chords, so it's got to be using chord theorem 3. So using chord theorem 3, it says here that if OM is perpendicular to AB, which we've got, so we've got OM is perpendicular to AB, so we're given that, then AM must equal to BM. So that's what we're told. So using chord theorem 3, we know that AM is equal to BM. Alright. So using chord theorem 3, or you can draw the symbol, which looks like this, equal. Using chord theorem 3, what do we know? We know that AM is equal to BM. And we know that from A to B, it's 10 centimeters. So we know that AB is equal to AM plus BM because it's the whole distance across. So AB is 10 centimeters, and if AM is equal to BM, then 2 lots of AM is 10. So AM is 5 centimeters. And that's by using chord theorem 3. Now chord theorem 3 also has a part 2, so that we know angle AOM is equal to angle BOM. Alright, so let's use that. So we know that using chord theorem 3, angle AOM is equal to angle BOM. Alright. We know that angle AOB is 92. Now, similar trick to what we did with the line segments, AOB is the sum of AOM and BOM. Oops, AOM plus angle BOM. So if AOB is 92 degrees and AOM is BOM, then 92 degrees is twice of angle AOM. In other words, angle AOM is half of 92, which gets me half of 92 is 46 degrees. So therefore, AM is 5 centimeters long and angle AOM is 46 degrees. And that's pretty much it for part 1 of circle theorems. So there's 4 circle theorems you need to learn. For now, just work with a cheat sheet next to you while you're doing these questions. And that's a to-do list. Remembering in year 10, we're not proving any of these theorems, we're just applying them. So you don't have to worry about anything after question 10. So question 11, 12, 13, ignore those for year 10. And that's pretty much it. Have fun.